Hi guys, this is Ernest and welcome to our Ernest Sciences and Mathematics TV channel. Now today we are going to have a discussion on one of the organic reaction, or rather organic reaction types, and that is the halohydration reaction. Basically from this particular title we are going to see that this entails the addition of what we refer to as the water halogen, and we can be able to give an example of this particular illustration. So in our first case we will say that X is going to represent halogens, or a halide molecule in this particular case, and the concept of OH group, this is a derivative of the water from the H and Ac positive. So therefore we're going to consider this this molecule and this one halide molecule in trying to see how that general example, as we have previously illustrated in one of our videos, or rather our previous videos on the reaction that entails the concept of alkenes and other functional groups. So if we try to look at this, then therefore we're going to have this one given as such, whereby we're going to see that analogous to the formation of the physical dihalides that we had given, so therefore this OH group is going to be attached at this specific point, and the X group is going to of course form in this particular part. So if we try to look at this, of course we can consider the case whereby we had said that X is an halogen, and this is going to be of course displayed in this particular discussion using a dihalide molecule, and we are going to consider and use the case of a bromine, which we had illustrated as having thus specific bonds. So therefore we are going to consider the case of bromine reacting with this specific molecule, therefore in the presence of what we refer to as water and a bromine molecule given as such as the reagents. So therefore we're going to see that the behavior of this is going to be similar to the illustrations that we have had in our first case for hydration reaction, whereby this electron-rich part is going to have an interaction with that one, and then therefore we're going to have a bromide, of course, acting as a living group, and this of course is going to lead to the formation of what we refer to as a secondary carbocation that consists of a bromide molecule, and then we have that one appearing as that specific point. So this is going to have an interaction with the water molecule that of course we had illustrated using this specific example. So this is going to pick on that one, and this is going to lead to the formation of an intermediate that is going to be illustrated as this. So therefore this is going to be an intermediate that has a positive charge at that specific point, and we can be able to illustrate this specific part whereby we're going to have a bromide group at that specific point. So if you try to look at this particular ion, therefore this is going to lose a proton, and this is going to lead to the formation of this final product, whereby we have a OH group and a bromide group attached at that specific point. So therefore the transition from this specific point to this one is going to follow this route that is going to lead to the formation of a secondary carbocation that is going to interact with the water molecule to form this intermediate, and therefore we're going to lose this proton, which is going to be of course leading to the formation of that final product. So therefore if we try to look at this specific reaction, we're going to look at the concept of epoxidation in a separate video, of course, which is also going to take the same format as the discussion that we have had in this specific topic. So if we try to consider this one, of course we're going to look at that one in the concept of what we refer to as epoxidation, and if the final product that we have had in this particular case, then therefore we're just going to reserve that one in that particular discussion for epoxidation reaction. Now of essence for us to understand this, the rearrangement that is going to lead to the formation of these two specific groups, which have basically attached to the carbon-carbon double bond functional group. So therefore if you try to look at another perhaps example that is going to take this format, it's just going to assume the same mechanism. So therefore we shall just reserve that one for another discussion. Understood the concept of halohydration, which basically assumes the same. So that is it for now, guys. Bye. God bless you. Catch us in our next video.